So here's where we are now in the class. You can see we've done quite a bit. Maybe you're getting tired of math, but we've got more to go, so we'll keep moving ahead. So we're moving from sort of general pollution transport equations into how to predict pollution movement in more specific environments. So we're going to start with surface water, and then later on in the class we'll talk about below ground, groundwater and soils, and how pollution moves through air or the atmosphere. So we're starting with surface water. So this video is just going to be an introduction looking at the types of surface water and pollution sources. This may be a little bit of a review for you, but it'll get us all sort of on the same page and knowing what is coming up. Okay, so first we're going to talk about rivers. And sort of the defining characteristics of rivers are that there is a downstream current, they have turbulent flow, and a big part of pollution transport can involve sediment transport. So a lot of the modeling and prediction that we'll do deals with the relatively simple equations for predicting where pollution moves and how it moves through a river. This is one of the only surface water types that we can use relatively simple equations for, so we're going to spend more time talking about rivers than other types of surface water. So lakes are the other surface water type we're going to talk about. As you probably know, there's no persistent downstream current in lakes, and they are often vertically stratified, particularly in the summer, with a warm layer on top, a thermocline, and a cool layer. And this can really impact how long pollutants stay in lakes or how they get transported in and out. So modeling transport can be fairly complicated. So we're just going to use mostly mass balance models, things that we've already done quite a bit of. We'll just make them a little more realistic using things like lake stratification. And there are more complex mixing models that are sort of computer models that are used to predict things like when is there going to be an algae bloom in Lake Champlain. So we're not going to be looking at those, but they are out there, so you should be aware of them. And then finally, estuaries, and these are the interface between rivers and the ocean. So there are tides, there are currents, they can be vertically stratified due to temperature and salinity. So as you may guess, they're fairly complicated to model, and there aren't any simple equations to deal with pollution movement in these settings, but we will be using a NOAA transport model to investigate how pollution might move in these areas. Okay, so that is the different types of surface water, and now pollution sources is probably something you've covered before, but I just want to make sure that we're kind of all thinking along the same lines. So pollution sources for surface water, obviously point sources, discrete, localized, usually pretty easy to measure and also to control. Things like spills or broken pipes or sewage outputs, things like that. The more difficult situation is non-point sources, and I think Amanda also touched on this a bit in her talk last Tuesday. So non-point sources are more difficult to measure because they come from a large area with many sources, things like agricultural runoff, urban runoff. They can enter streams through overland flow or groundwater, or can even be transported in on air. So some examples are agricultural, fertilizer, and pesticide runoff, as well as urban runoff, which you heard Amanda talk about in how she's trying to use her stormwater gardens to mitigate urban runoff problems. All right, so the next video we're going to start talking about physical transport of pollution in rivers and using some simple equations to predict how pollution moves downstream.